A value curve is a simple graph that shows how a product or service performs on the factors that customers care about. Imagine drawing a picture of a pizza. The crust, sauce, cheese, toppings, and price are the factors along the horizontal axis. For each factor, you give a score from 0 to 5, where 0 means no offering and 5 means industry-leading offering. The vertical line shows the score. Plot the points and connect them, you get the company's value curve. Quantitative analysis starts with data collection. Suppose 3 airlines compete on 4 factors: ticket price, legroom, flight frequency, and loyalty points. You ask customers to rate each airline on each factor from 0 to 5. Let S sub ij be the score of airline J on factor I. The industry average for factor I is V sub I equals open parenthesis 1 over n close parenthesis times sigma j equals 1 to n of S sub ij, where n is the number of rivals. If the new entrant wants to create a blue ocean, it can deliberately choose scores that are very different from the V sub I line. For example, very low price but very high legroom and loyalty points. The numerical gap, absolute value of S nu sub I minus V sub I, tells you how far you are moving away from the current market red shape. And the total distance across all factors, sigma of absolute value of S nu sub I minus V sub I, can be used as a simple differentiation index. The example helps students see that a value curve is not just a picture, but a set of numbers that can be compared, summed, and plotted. The 4 actions framework asks you to look at each factor in the industry and decide whether to eliminate, reduce, raise, or create it. To turn the ideas into a decision tool, build a scoring matrix with 4 rows: eliminate, reduce, raise, create, and columns for each factor. Give each cell a score from 0 to 5. Next, assign a strategic weight W sub k from 0 to 1 to each action, based on how much impact it is expected to have on profit or market share. The total action score equals the sum over k from 1 to 4 of W sub k times the sum over I from 1 to m of a sub ki, where a sub ki is the score for factor I under action k and m is the number of factors. Example: a coffee shop chain looks at 5 factors: price, speed, ambience, coffee quality, and loyalty program. It decides to eliminate high price specialty drinks score, 4 weight.2, reduce waiting time score, 3 weight.3, raise brew quality score, 5 weight.4, and create mobile ordering score, 5 weight.5. Plugging the numbers gives a clear numeric justification for the strategic shift. The matrix turns vague strategic words into a transparent comparable score that MBA students can calculate and defend. The strategic canvas is the visual board that shows all competitors' value curves side by side. To make it data-driven, first list every key factor, for example safety, speed, price, service, in a table. For each firm, collect the quantitative scores 0 to 5 for each factor. Then apply a statistical standardization so you can compare factors that were measured on different scales. The most common method is the z-score. Z sub ij equals x sub ij minus mu sub I divided by sigma sub I. Where x sub ij is firm J's raw score on factor I, mu sub I is the industry mean for factor I, and sigma sub I is the standard deviation. The z-scores become the data points plotted on the canvas. The line for each firm now reflects how many standard deviations it is above or below the average. Example: 3 ride-sharing apps are compared on price mean 3.2, standard deviation 0.6, waiting time mean 4.0, standard deviation 0.5, and safety rating mean 3.8, standard deviation 0.4. After z-scoring, the canvas instantly shows which app is a true outlier on safety, even if its raw score looks only slightly higher. This quantitative canvas gives students a solid way to argue that a blue ocean move is statistically significant, not just a visual impression. The buyer utility map is a 6x6 grid that matches the 6 utility levers: customer productivity, simplicity, convenience, risk reduction, fun and image, environmental friendliness, with the 6 stages of the buyer's experience cycle: purchase, use, maintenance, disposal, etc. To turn the map into a scoring model, give every cell, lever times stage, a utility score U sub LC from 0, meaning no benefit, to 10, meaning maximum benefit. Next, assign a weight W sub L to each lever, which reflects how important that lever is for the target segment, and a weight W sub C to each stage, which reflects how much time the buyer spends in that stage. The overall weighted utility is capital U equals the sum over L equals 1 to 6 of the sum over C equals 1 to 6 of W sub L times W sub C times U sub LC. Example, a new streaming platform scores high on convenience during the use stage. U equals 9, W convenience equals 0.25, W use equals 0.30, and on fun and image during purchase. U equals 8, W fun equals 0.20, W purchase equals 0.15. Adding up all 36 weighted cells yields a single number. For example, U equals 6.8 out of 10. That can be compared to competitors' totals. The model lets students quantify how much extra utility a blue ocean idea creates across the whole buyer journey. The Blue Ocean Idea Index, BOII, is a one-page formula that tells you whether an idea is worth pursuing. The classic formula is BOII equals utility score times willingness to pay divided by cost to serve plus implementation risk. Each component is a normalized score from 0 to 10. Utility score comes from the buyer utility map. Willingness to pay reflects the premium customers are ready to pay, survey price elasticity. Cost to serve is the internal cost per unit, higher cost lowers the index. Implementation risk is a composite risk rating, technology regulatory market. The numerator captures the value created, while the denominator captures the price you pay for the idea. Example, an electric bike startup gets utility score equals 8, willingness to pay equals 7, cost to serve equals 4, risk equals 3. BOII equals 8 times 7 divided by 4 plus 3 equals 56, divided by 7 equals 8.0. A rule of thumb taught in MBA programs. BOII greater than or equal to 5 signals a viable blue ocean, below 5 suggests redesign. Students can plug real numbers into the formula, compare multiple ideas side by side, and make a data-backed portfolio decision. Monte Carlo simulation is a statistical way to see how a new market might perform when many variables are uncertain. Step 1. List key drivers, for example total addressable market, abbreviated TAM, adoption rate, price, variable cost, and fixed cost. Step 2. Choose a probability distribution for each driver, such as normal, triangular, or log normal. Step 3. Generate a random value for each driver and compute the outcome, usually net present value, using the formula. Net present value equals the sum from T equals 1 to T of revenue T minus cost T divided by 1 plus R to the T power, where R is the discount rate. Step 4. Repeat steps 2 and 3 many times, 10,000 or more, to build a distribution of net present value outcomes. Step 5. Summarize with mean, median, 5th percentile, which is the worst case, and 95th percentile, which is the best case. For example, a plant-based meat brand estimates total addressable market about $2 billion, with a normal distribution mean 2 and standard deviation 0.3, adoption rate between 5 and 15% with a triangular mode 10%, price $5 per unit, variable cost $3, fixed cost $30 million, and discount 10%. Running 10,000 simulations produces a net present value distribution with a mean of $12 million, 5th percentile negative $2 million, and 95th percentile $30 million. The probability of a positive net present value is about 73%. This quantitative risk picture helps students argue whether a blue ocean venture passes the risk-adjusted return test. Explanation: to compare a blue ocean idea with a red ocean competitor, build a metric matrix that scores each side on 4 dimensions. Market growth 0 to 5, profit margin 0 to 5, entry barriers 0 to 5, and customer lock-in 0 to 5. Compute a weighted composite score. Score equals sum of W sub D times S sub D for D equals 1 to 4, where W sub D are strategic weights. For example, growth equals 0.4, margin equals 0.3, barriers equals 0.2, lock-in equals 0.1, and S sub D are the raw scores. Example: traditional taxi services. Red ocean. Score 2, 3, 4, 3 leads to composite equals 0.4 times 2 plus 0.3 times 3 plus 0.2 times 4 plus 0.1 times 3 equals 2.9. A new autonomous shuttle service, Blue Ocean. Scores 5, 4, 2, 5 leads to composite equals 0.4 times 5 plus 0.3 times 4 plus 0.2 times 2 plus 0.1 times 5 equals 4.5. The higher composite tells you the blue ocean has a stronger strategic position according to the chosen metrics. By changing the weights, students can test how sensitive the comparison is to different strategic priorities, reinforcing the idea that blue ocean advantage is measurable, not just anecdotal. 1. Using the following raw scores for 3 airlines. Price 234, legroom 325, frequency 442, loyalty 153. Compute the industry average value curve and the Euclidean distance of a new entrant with scores. Price 1, legroom 5, frequency 5, loyalty 5 from the average. Answer: V equals open parenthesis 3, 3.33, 3.33, 3 close parenthesis. Distance equals square root of open parenthesis 1 minus 3 close parenthesis squared plus open parenthesis 5 minus 3.33 close parenthesis squared plus open parenthesis 5 minus 3.33 close parenthesis squared plus open parenthesis 5 minus 3 close parenthesis squared close parenthesis approximately 4.08. 2. Fill a 4 actions scoring matrix for a smartwatch startup that decides to eliminate large screen, reduce battery life, raise health sensors, create AI coach. Give each action a weight: 0.2, 0.3, 0.4, 0.5 and factor scores. Eliminate equals 4, reduce equals 3, raise equals 5, create equals 5. Compute total score equals 0.2 times 4 plus 0.3 times 3 plus 0.4 times 5 plus 0.5 times 5 equals 4.9. 3. A buyer utility map gives the following weighted utility. Sigma W sub L times W sub C times U equals 6.8. If the competitor's utility is 5.2, what is the utility advantage? Answer: 6.8 minus 5.2 equals 1.6, 20% higher. 4. A Monte Carlo run for a new app yields net present value mean $8 million, 5th percentile negative $1 million. What is the probability that net present value greater than 0 if the distribution is symmetric around the mean? Approximate answer: about 55 to 60% since the negative tail is small. 5. Using the Blue Ocean Idea Index formula, calculate BOII for an idea with utility equals 7, willingness to pay equals 6, cost equals 3, risk equals 2. BOII equals open parenthesis 7 times 6 close parenthesis divided by open parenthesis 3 plus 2 close parenthesis equals 42.